This internal combustion engine runs on hydrogen, a zero carbon fuel.
People confuse anything to do with combustion is bad, but if you're burning a zero carbon fuel, you're producing zero carbon from that combustion process.
The hydrogen engine has been retrofitted into this diesel truck as a proof of concept. It's hoped this approach could be an efficient way to decarbonise a wide range of vehicles using existing supply chains and infrastructure.
There's a huge supply chain or a huge value chain, you can think, built up around internal combustion engines. So managing the investment to transition to a carbon technology, this is a real breakthrough, because with relatively small changes, we can scale this from small vehicles to large vehicles, from on-highway to off-highway, from off-highway to mining. So it can just be applied across many different segments at an accelerated pace with a manageable total cost for the whole industry.
Cummins builds around 70,000 diesel engines a year in the UK, which is a world leader in the production of heavy-duty powertrains and vehicles. But from 2035, all new HGVs weighing under 26 tonnes sold in the UK must be zero emission. That's an existential challenge to a sector that contributes significantly to UK GDP and exports. The hydrogen internal combustion engine was developed by a consortium led by Cummins and supported by the APC as a potential solution to this challenge.
Together they've developed and proved out a 6.7 litre hydrogen engine, and they've proved that it can achieve the durability that they'd expect, and crucially that it can achieve the ultra low emissions. So it's been a really successful project, and really exciting to see what they've achieved.
All combustion engines produce some nitrogen oxides, which are often called NOx. The Cummins hydrogen engine carefully manages the combustion process to minimise the amount of NOx produced, and an after-treatment system developed by Matthey can reduce this to effectively zero using familiar catalyst technology.
Unlike diesel, where you have CO, hydrocarbon, soot, you haven't got any of those in a hydrogen engine. The only thing you've got is a little bit of NOx and some hydrogen. Hydrogen burns extremely easily, so any precious metal in the system will remove any hydrogen slip. We then have a catalyst where we inject urea, ammonia onto to remove the NOx, and that basically removes 100% of the NOx. So basically there should be nothing coming out of the exhaust system.
Zircotec developed a range of special coatings to protect the engine from hydrogen embrittlement.
We developed a range of ceramic coatings which would block hydrogen from permeating into the metals. When hydrogen enters metals, it can cause embrittlement, it can cause cracking. So we developed a range of coatings that stops that cracking from happening in critical engine components.
Phinia developed the injectors to deliver the hydrogen into the cylinders efficiently.
We've learned an awful lot from this technology, from APC18. We've learned how to handle hydrogen, so we built hydrogen test cells. We've got a single cylinder engine running with different injection strategies. The understanding transfers to injection systems, not just for combustion engines, but also for fuel cells. So we've picked up a project to engineer an injector for a fuel cell, for example. All of this is from the APC18 project.
Cummins believe the APC funding and support has positioned the UK as a global leader in this low-carbon, high-value transition technology.
The fact that we were able to leverage the funding from APC, that enabled us to get on board and make that first step in advance of many other companies, in advance of many other countries, and be at the forefront of hydrogen engine development. So that, I think, has really positioned the UK really well.
Cummins hopes that the rollout of hydrogen internal combustion engines could be a faster way to decarbonise sectors like heavy goods vehicles and mining, because we already have most of the required skills, supply chains and infrastructure.
So rather than having to wait many years until the infrastructure for charging points is rolled out, we can implement hydrogen much quicker than that, with 99% reduction in emissions over where we are today. So rather than that postponed perfection, we think we can get hydrogen in the market a lot quicker and make a bigger impact to the environment.
To find out more about this hydrogen internal combustion engine and the work of the APC in accelerating our progress towards low carbon transport, visit apcuk.co.uk.